Hello and welcome back to NTMAU. And in this problem, what they want to do is solve for what the height is. That means the distance from this surface here, coming all the way across, to this surface right up here. And to do that, they give us some relevant information to help us to solve for the problem. To begin with, we're sticking with the A as 50 degrees. That's this angle. And Z is 3 inches, 3.307 centimeters, so that's what this is here. And then V is 5.212 centimeters, that's this distance here. They also give us in this the side adjacent, which is 9525 or 952.5. That means that this distance from here to here will be 0.9525 or 952.5. Why? Because this is going to be the adjacent side. Now let me sketch up a few things for you, and we can take the problem from there. Alright, the first section is this. We know that we've got a few things that we've been told that we have, and that is the distance from here to here is 952.5. The distance from here to here, this point here to here, is 952.5. Alright, that's this piece right here. The next thing that we know is this becomes the angle inside here. We know that it is 50 degrees because it tells us that. It tells us that A equals 50 degrees, so A is 50. So let's go ahead and break that down. Okay, now I filled everything in with the dimensions that they've given us, starting with the Z. Z is 3.307. That's right here. Distance angle, I should say, A is 50 degrees. That's 50 degrees here. I've created it also over here. Distance V is 5.212. That's right up here. We know that we have 952 and 5/10 right here. So what we're going to do is we know that this surface here, the distance from here to here, is the adjacent side because it's next to the given angle of 50 degrees. So all we really have to do is solve for this distance right here, or this leg right here, which makes that the opposite side, right? The one on the top is the one you're looking for. The one on the bottom is the one that you would have. And if we have the opposite, let's go ahead and sketch that up. Okay, so we have the opposite over the adjacent equals the tangent. The opposite side, that's what we're looking for, that's this distance here, over 952.5, that's this distance right here, equals the tangent. So the tangent of what? Well, in this case, it's going to be the tangent of 50 degrees, right? So what we're going to do is plug into the calculator first. And what we know from past is that we're going to move this on this side of the equal sign, right? And we know that if we're moving this to this side of the equal sign, it isolates this to be by itself. This is division. When you move a number to this side of the equal sign, it's opposite of what you have on this side. So that means that it is going to be multiplication. So the first thing we're going to plug into the calculator is 50. 50. And then you're going to hit your tangent key. And then you're going to hit the equal sign, and then you're going to hit the multiplication key, and then you're going to hit or plug in 0.95525. When you do that, that's going to give you the distance from here to here. Simple as that, right? Okay, I hope that helps. Your answer should be the 1.1351 or 1 inch or 1 centimeter, 0.135 and 1/10. Okay. In this case, you didn't need this information. You didn't need this information, but it's always good to write everything down. One of the things that I've always learned whenever I calculate out any kind of a math problem at all is write down all the information that you have, all the information that they give you that pertains to that angle. Why? Because you never know whether or not you're going to need it or not until you actually get into the problem. The thought behind that is this: if you don't write this information down, even if you don't need it, but if you don't write it down, all you'd be doing is looking at the paper, the page, the way that it was originally set up. So write it down, set up your angles. Always try to start a problem around the circle, because anywhere where they have a radius or a circle or a tangent point or anything like that, I would have to say 90% of the time that is where the problem is worked from. In this case, that's not what happened, but I would say 90% of the time it is. Okay, that's it for this video. I hope you had a good understanding of it, and I'll see you on the next one.